So here we are. It's February 10th. It's 9:08 a.m. I got an email from some folks. Okay, from one person. I got an email from one person. They said, question number 27 is just driving me crazy. Those aren't their exact words, but they said, I'm having trouble doing number 27. And I'm going to do number 27. This is very, very similar to question number 26. This is a combustion analysis question. Now, the version of the question or the iteration of the question that I have is going to be a little bit different from yours. What mine tells me is that I have 17.0 grams of CO2 and 7.81 grams of H2O, and that is the result of the complete combustion of 5.5 grams of a hydrocarbon. Okay, that word right there, hydrocarbon, is one that is fairly telling because it basically gives you the information that you need with respect to, well, what's it made up of? Hydro, meaning hydrogen, and carbon, oh, this is a fun one. What could carbon mean? Well, it means carbon. So this is a compound that has nothing but carbon and hydrogen. So that word is going to be a clue. So this is asking for the empirical formula. So it's going to give you a formula that is something like this. C sub X H 8. Oh, not 8. I don't know why I wrote 8. Instead it would be something like Y, a variable that we have yet to determine. So there's no oxygen in this. We don't need to worry about oxygen. The question doesn't even mention oxygen. All that it mentions are the products, CO2 and H2O. So what we're going to use this for is we're going to use this to figure out, well, the number of moles of carbon and the number of moles of hydrogen that result. Okay, so what I'm going to do is I'm going to start out with 17.0 grams of CO2. The molar mass for CO2 is 44 grams. CO2 is 1 mole of CO2. Now, after I figured out the number of moles of CO2, I want to relate that to the number of moles of carbon. I know that if I have 1 mole of the molecule CO2, then I have 1 mole of carbon, because for every CO2 molecule, there is 1 carbon. Okay, so I'm going to say 1 mole CO2, 1 mole carbon. And I'm going to solve this right here. So 17 times 1 times 1 divided by 44 gives me 0.3, I'm going to say 0.386. Now the next item, hydrogen, 7.81 grams of H2O. And my molar mass for H2O is somewhere in the area of about 18 grams of H2O. Is 1 mole of H2O, 1 mole of H2O. I have 2 moles of hydrogen. So what I'm figuring out is the total number of moles of carbon and hydrogen. That's all that I need. Now, 7.81 times 1 times 2 divided by 18 is 0.867. Okay, so basically I've got this. C sub 0.386, H 0.867. I divide each of these by 0.386 because that's the lower number of the two, 0.386. And that's going to give me C1, H 0.867 divided by 0.386. 2.2. Okay, 2.2. What am I going to do with that? Now, this is something that we didn't look at yesterday, but think about it this way. Could we take this 2.2 and make it a whole number? I think we could. And the way that we would do that would be, the way we're going to do this is by realizing that I made one simple mistake, and that is my number that's not 2.2. I want to take that to 2.25. Okay, so there was my slight miscalculation and detail that I overlooked. Okay, now looking at these two numbers, well, I don't want to necessarily divide anything because I don't want to break that whole number 1 down any further. But let's say that I multiplied this. I multiplied 2.25 by 4. That would be 9. So 2.25 times 4. Okay, now it would mean, and I can do that because then all that I do is I take my H and I bring that subscript, or I raise that subscript. So what should I do to the subscript for carbon? The exact same thing. So I should raise that to 4. So C4H9 is the answer that I got for that question. I hope this was helpful. Have a good one.